Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to our virtual tech talk. My name's Tobias, and on behalf of the Arm AI ecosystem team, I'm thrilled that you could join us today, wherever you are joining us from in the world. Again, if you've not been to one of our tech talks before, particular warm welcome to you. This tech talk series is all about bringing together brilliant minds from the world of AI, from our partner ecosystem that we have of amazing companies that specialize in various fields of AI, and speakers from Arm as well, talking about all kinds of the latest trends, topics in this incredibly exciting world of artificial intelligence and machine learning. So we've got a bunch of talks coming up. We're also really excited to have a jam-packed July coming up in the next two. We've got Arcturus and NXP joining us on July the 13th. And then just a week after that, on the July the 20th, we've got Arduino talking about Easy Tiny ML, right where things are happening. So please make sure I'll be posting a link shortly in the chat. So do take a look at that. If you want to register for upcoming talks, they promise to be really, really exciting ones. We aren't going to run any tech talks in August. We're going to take a bit of a summer break, but rest assured we'll be right back in September. And we're also really excited to have an expansion to the Tech Talk series, which we'll be announcing very, very shortly. So today, let's get to today's Tech Talk. I'm thrilled to be joined by an amazing company called Nota.AI, and particularly joined by their CTO and co-founder, Taiho Kim. Nota.AI are an amazing company based in the APAC region. I believe it's Korea. They're an amazing company who've been in our ecosystem for a while, and we're thrilled that they could join us at quite an unsociable hour for them, I have to point out. It's about midnight where they are. So I'd love to introduce these guys from Korea, from Nota.AI. They're an amazing company, and they've really got something incredible to talk to you about today. So without further ado, Taiho, do you want to come off mute, put yourself on camera, and introduce yourself with your bio? I'm surprised that you're awake at midnight. It's great to have you at this late hour where you are. We're thrilled to have you joining us today. And you're going to talk about NetsPresso and really fast inference on Cortex-A. So straight over to you. Take it away.
Okay, thank you for introducing us, Tobias. Hello, everyone. I'm Taeho Kim. I'm CTO and co-founder of Nota. And I'm really happy and it's a pleasure to have a presentation in front of you. And it might be a first few chance to make a presentation for you guys. And I'm going to present this slides, and the title is for introducing NetsPresso, and it's of course made by us. It's for really fast inference on Cortex-A devices. So this is my short introduction for myself. So I graduated KAIST in South Korea, and I have short research collaboration with University of Montreal and Chinese University of Hong Kong. And my main research interest area is a very wide range of deep learning all over the world, all of the applications. And today, I assume that many people are here, and your background of deep learning and in comparison is very various. So I made a slide. I made slide for people who are familiar with deep learning or who are not familiar with deep learning. And if you are familiar or not familiar with compression, I made very brief introduction of the compression deep learning. So I want to start at this point. So as you know, achievement of learning is very common story. AlphaFold 2 and DALL-E or any CLIP, these kind of very great deep learning papers and deep learning models are in the world. And we are seeing the very flatly changing this industry and all of the applications. So we can see the futures coming. And as you know, deep learning shows very great achievement and very astonishing performance, but it is known as very huge. And it means that GPT-3 is one of the very famous model in NLP area, and GPT-3 is one of the most well-known model. and each has around 178 billion parameters. It's very huge, and we are very obvious that the next model will have much more parameters. And I said about GPT-3, and GPT-3 has 175 billion parameters. Then how big? So we have to know the sense of this number. So when we train this model, it takes around 355 GPU years with one GPU, and it takes around $4.6 million. And when you want to run this model on the GPU, the GPU requires around 700 gigabytes. When you consider that each GPU has around 40 or 50 gigabytes, then we need a lot of clusters for inference this model. So this kind of AI applications are mostly run on the cloud. It means that its cloud-based AI has some properties. So the firstly, if the number of users and number of user applications increase, then the uses of the cloud-based AI goes up as well. It means that the cost goes high and is a very big problem for the company. And the second property is that the cloud-based AI has a problem with privacy. If you want to run the AI solution for the customers have to upload their data to the cloud. It means that users' privacy can be very issue. And the third property is that about network connectivity. If you go any places where the network connectivity is not stable, then if the AI is on the cloud, and if the network has some problem, then AI cannot run for that area. So this kind of three properties makes cloud-based AI unsustainable. So this kind of properties or problems can be solved with edge AI. So edge AI, so I call it as an AI model compression here. So when we run the model not on the cloud, but on the edge AI, then we don't need any scalable cost. So low cost can solve the problem and users don't need to upload their data. So privacy concerns does not concern anymore. And, and also network connectivity is not an issue. So standalone AI model can run on the edge AI. So AI model compression can solve those kind of problems. So how can achieve the kind of edge AI? So I divide four areas for making the edge AI or tiny ML, those kind of things. So first part is model training. So we need the model at the first. And next is model compression. When we prepare the model, then we compress the model into very small size. And third part is compile. So we need to compile the model into the language of hardware to make it very efficient. And next, the last step is deployment. So where our hardware is should be ready. So if the hardware is very efficient and it shows very good performance, then it is also part of this tiny ML and tiny applications. So I would like to introduce more details about the model training first. So if you want to train the model, there is a very two common ways. The first part is neural architecture search, also known as NAS. And NAS, what NAS is that? Let me change the later point. So um, deep learning structure is the block of the layers and blocks and the neurons. And this, the design and architecture of the deep learning model can be um, assembled from these blocks. And so it means that if the search space of the model is designed at first, there's a search strategy to pick up the model from the search space. And this picked architecture is estimated its performance and it returns the performance. And the search strategy. Oh, if the model, if this kind of model shows this kind of performance, I can adjust the model into that way or that way. Then this search strategy pick another exception from the search space, and again, it estimates the performance. This kind of loop is the basic philosophy of the NAS, and it also has the gradient-based or reinforcement-based learning-based NAS. And more common way to prepare the model is the just use the popular model and popular pre-trained model. These kind of all models, most of models are already public, and its pre-trained model on the ImageNet is already ready on the website. So we just download the model from the TensorFlow Hub or um, the Torch Vision, then we can just fine tuning on your own data set. If the model training is ready, then we do the model compression and compile and deployment. And I would like to introduce more details of the deployment. So including Arm, it's many hardware companies are making this awesome hardwares. So for example, Arm shows four kind of lineup for the HAI. The first lineup is Cortex-A, and it includes GP Mali and Exos N78 series. It is prepared for very high data throughput applications, and also including Cortex-A, Cortex-M, and Asus U55 and U65, and Cortex-M series are also a part of this AI, HAI, the word. And among these kind of hardwares, this ARM Atos N78 is very wonderful, and it's a second generation NPU. It is a standalone processor for the machine learning, and it includes the more than 100 unit configurations with 8 the configuration. So among these four stages, Nota is focusing on the model compression. Model compression, it contains a lot of the branches, the filter decomposition, the knowledge distillation, network pruning, and quantization. So maybe some of you are not familiar with the compression. I want to introduce a little bit of each compression techniques. The first part is filter decomposition. So standard convolution filters. So convolution is the one of the most basic unit for the deep learning models, and it is the most it is the operation which have the most portion of the operation in the AI model. So standard convolution filters is it can be divided into another form of the operation. So we call it depth-wise separable convolution. So this kind of approximation is called filter decomposition or low-rank approximation, tensor decomposition. The kind of words are also works for this area. So this kind of approximation of the filter can save the cost. So including the depth-wise separable convolution, network decoupling, truncate SVD, Taka decomposition, CP decomposition, these kind of techniques are the examples of the filter decomposition. And another field of the compression is knowledge distillation. So we have two models here, teacher and student. So we extract knowledge from teacher and we distill this knowledge to the student. That is the basic of the knowledge distillation. So here, teacher is the original model. So it means the pre-trained model. And student, it is a compressed model. So if the teacher extracts the knowledge, so it means the original model extract the knowledge, then each knowledge can be the target of the student, and this student can learn from the teacher. So the compressed model not only takes the training from the level of the data set, but also takes knowledge from the original model. So it shows the better performance and better accuracy comparing to the not using this teacher model. So this knowledge distillation has various branches inside. So those are the feature distillation, soft label, or attention distillation. And many examples can be in here. It could be KD, FinNet, overall KD, or relation KD. Many other KD techniques are developed in these days. The third technique is network pruning. So it means that as the name says, we prune any things from the network. So based on the unit, what unit we are going to prune, the name of the prune is different. If we prune the synapse or the weight, then we call it unstructured pruning. If we prune the neuron or channel or any filters, then we call it structured pruning. It is known that unstructured pruning is not efficient because it just makes zeros inside of the matrix, but not actually removing the or removing or reducing the size of the matrix. But structured pruning, it actually reduces the size of the matrix. So it is very obvious that structured pruning can save the computation cost. And so how can we decide which neurons should be removed? Then many kind of metrics are in the state, L1, L2, GM pruning or batch prunings are the examples. And if we compare so when we remove these snaps, so when we remove these snaps, the decision criteria is, and the comparison is going on this layer, then we call it local pruning. But if we uh, collect all the synapses into the one place and we sort it and we remove it, then we call it the global pruning. So if the scope is changed, the name goes different. Then I want to introduce one paper here, which is developed by Nota, and the title is toward compact deep neural networks via energy-aware pruning. So here we use the nuclear norm. So um, in the given the data set, we forward propagate some batch on the model, and in the feature map, we compute the SVD and also we measure the nuclear norm, and based on each channel, and we just sort this nuclear norm value of each channels, and we set the threshold if the nuclear norm of the filter is below the threshold, we remove that channel. That is the basic idea of the paper, and we show the qualitative result shows that the comparing to many other pruning techniques, nuclear norm shows the same decision boundary as the original model, but the other pruning method, its decision boundary shows some cracks and some different some decision boundaries compared to the original model. And also the quantitative result shows that the proposed model method here, the nuclear norm pruning, the previous SOTA model was H ranked, but we shows better result and just better the reduction of the flops. So including this pruning method, our Nota made many compression methods in the, okay, say our inside of the company. And the next technique I'd like to introduce is about quantization. So as you know, bit is a 0 or 1. So if we have 2 bit, and we can represent 4 numbers. And if we have, 2 bit, then we can represent two numbers. So quantization means that if the model is represented in 32-bit floating point, then if we do quantization, all the values are represented in 2-bit, and this 2-bit can be let's say dequantized or requantized. But the benefit here is that actually the 32-bit compared to 32-bit, 2-bit shows much reduced the size of the space memory, and it also shows the better operation speed and the latency. And many examples of the quantitation techniques are here, Dolpha, PACT, and Quick, and TQ. So it is very also well-known techniques. So far, I introduced about the many basic things about the let's say the properties of the cloud AI and the problems of the cloud AI and how can we solve the problem and the four main areas and stages for preparing the tiny ML. And including these four stages, I introduce more of the model compression. And this model compression has many branches of the techniques, and many other techniques and papers are actively ongoing in that field. So from now on, I will introduce about the Nota a little bit, and I will introduce how Nota is solving that AI model compression problem. So it's the very basic and brief introduction of the Nota, this company. So Nota is uh, founded on 2015, and uh, we have many investors, and currently we are focusing on the model compression area for the main business area. So we have four branches on the all over the world, in Berlin and San Jose, Daejeon, and Seoul into South Korea. So our branches, and including inside our members, more than 70% people are in the R&D part for engineering. So we have more than um, 20 clients and 30 references for our model compression and model solution of the model compression. So we have two main area of the business portfolio. The first part is AI model development, and the second part is AI model compression. So here, AI model compression means that we do model compression for the company or the customer. So given the model, we do the compression, we return the model. And the other part is that we build our own AI model solution. So we develop our DNS solution, our hand gesture recognition model, our inventory management system on the very tiny ML perspective. So I will introduce more of the AI model compression. So conventionally, AI model compression is done like this. Given the pre-trained model, we apply compression techniques, including pruning and quantization and etc. And we return the compressed model. But this kind of process we did a lot, and it shows some problems. The firstly, it is done by the DL engineers, and these say expensive DL engineers manually compress the model, and if the model number of the model increases and the effort and time and this laborers work goes increases as well. And compression methods are developed in different places and forms. Many papers and many GitHub repos are on the all around the world, but it is hard to understand and apply their techniques inside because it is hard to understand theirs, and all the authors are different and all the frameworks are different, so it's hard to use in the single place. And also, it is very hard to know which compression method or combination is best to use. So it is the area of the know-how. And also, compression metric does not fit to the practical metric. Many papers and it shows that max or number of parameters are their main metrics for um, assisting the greatness of their model. But in real world, max does not fit to the latency itself or data throughput because their hardware architecture is not um, very not fit to the model. Many other problems can be there. So these kind of problems are inside of the AI model compression. So we set these three um, problems to solve. The first one is that we want to make automatic compression without manpower. And we want to do combination of multiple compression methods. And we want to find any fitted metric for practical users. So the answer for this problem is NetsPresso. So we build automatic AI model compression platform, and this platform is for target task and any target data set for any target devices onto the target accuracy and latency model size, which of which customer wants. The NetPresso can uh, return the solution for the compression model for this criteria. And maybe this is the one of the most important slide of the today. So this is the architecture and structure of the NetsPresso. We have four kinds of input for the NetsPresso. The first one is pre-trained model. The second one is the target hardware. Third one is data set. And fourth is target performance. So when we get this kind of inputs, NetsPresso and are connected to the compression method pool. It means that we have prepared a lot of compression methods, around 14 to 15. So here we just write down very well-known techniques like L1 channel pruning, global pruning, standard, the separable convolution, group convolution, or the attention KD, overall KD. This kind of well-known compressions we just wrote, but we have more compression methods, including nuclear non-pruning. So NetsPresso do the compress with this compression item onto the pre-trained model. And when each step of the compression is completed, it means that if we apply overall KD on the pre-trained model, and this overall KD can return the model, and that model have to be tested whether this model have a good result or bad result. Then this model is sending to the device pool, and this device pool is connected to the real device, and the model is running on the device, and the device can return the performance and of the accuracy and latency. And that kind of metrics and the result is going into the hyperparameter optimization. And this hyperparameter optimization decide that, oh, that compression method was great, or oh, it was very bad. Then this hyperparameter HPO decide the next compression technique. So if OKD was great, then we can apply another compression technique on the next step. That kind of decision process is going on iteration. Then NetsPresso decide the whole pipeline of compression. Then the compression is applied to the pre-trained model. Then compression model can be written. Here, we get the input of the target hardware because we measure the real performance on the target hardware. Okay, so here was the NetsPresso, the structure of the NetsPresso. So, and inside, this is the demo video of the NetsPresso. It shows how NetsPresso works in. Okay, let me show you the demo video. Please note that the entire process took around 3 hours, so we fast forwarded it to capture the process within minutes. When you start running NetsPresso, it creates compression pipeline called recipe to find the appropriate compression combinations among pruning, FD, KD, quantization, and etc. To compare the performance after compression, NetsPresso evaluates metrics including model size, accuracy, and flops. NetsPresso starts its compression combination suggested by recipe. Also, NetsPresso compresses the model to work within the constraints. After each compression, NetsPresso runs post-training to further improve the performance. Now, it shows the result of the compression model. In this table, NetsPresso improves flops by 360% and parameter by 300%. Also, the model size is 1/3 of the original model. NetsPresso sends the model to target device pool and checks for inference. This model is tested on Raspberry Pi 3D Plus to make it 300% faster than the original model without compromising the accuracy. So here was a demo video of the NetsPresso, and in the demo video, as it said, so our NetsPresso is connected to the real Raspberry Pi, so it is optimized on that hardware. And I'd like to show you more benchmark table using NetsPresso. We have tested on uh, EfficientNet B0 and ShopNet V2, and this is a detection, mobile net button 3 and SSD Lite. So these two classification models were tested on the Xeon, and this detection model was tested on Raspberry Pi 3B Plus. And very surprisingly, accuracy of the efficient net and ShopNet V2 goes up a little bit, and is the detection model shows the lossless compression. Number of parameters is compressed around 80%, and its inference time is also compressed about 84%. And this ShopNet button 2 case, the number of parameters also goes about half, and its inference time is reduced about 86%. In the detection case, the flux is reduced about 65%, and its FPS goes really up about 50%. And it's more benchmark table on the classification model. We have tested on the Cypher 100 data set, and we have many the models. I want to highlight this mobile net case. Mobile net is very well known for hard one to compress. So many data engineers are suffered with mobile net, and when we do the little bit of the accuracy reduction, about less than 1%, then our the flux goes down on 5 times. The number of parameters goes down about 7 times, and what is size and its latency is also reduced a lot. So not only for compressing the model, we also have tested our NetsPresso on the various industry and various models. So here is the first use case of the NetsPresso is about facial recognition. So our facial recognition shows very good accuracy. It's about 99% of accuracy, and is this inference time and the latency is very small, and it shows also very good advanced security, and it's compressed model, so its model size is very small. We have two models. The first one is around 4 megabytes, and the other one is less than 1 megabyte. It is incredibly small size of the model. And we do have another use case is on intelligent transportation system. So we have tested our solution on the real case. Is the one cross of the can say in South Korea. We count the number of the vehicles on the light, and based on that information, we adjust the traffic light, and to reduce the traffic jam, and to increase the average speed of the vehicles. So we have prepared this model. Actually, this model is based on ResNet model. It shows around 150 megabytes, and it shows around 7 FPS. So at the case, in the rush hour, the vehicle shows around 10 kilometers per hour speed, and it was running on the cloud. But after we do compression, the model size goes around 100 times smaller than the original model, and the frame rate goes up in the real time, and its vehicle speed goes up as well. And we do the inference on the on-device. So far I have covered on the very basic and the fundamentals of deep learning and compression, and also I have introduced the NetsPresso, which is the automatic model compression platform. So and it also its use cases. So here today we have many audience. And I'd like to say that we are we are ready for the NetsPresso, and we are the let's say feedback from the people, and we want very people to use NetsPresso. So if you want to try NetsPresso, we can compress your model, and you can use NetsPresso yourself. So very we are happy and open to your email on this uh, address. So far, it was a presentation of the Nota and our solution on the TinyML, on the Cortex-A series, and hardware-aware for the compression platform. Thank you for your attention. And if you have any question, please feel free to have yeah, make let's say the question.
Thank you so much, Tahir. That was awesome. What a great presentation. And in half an hour, covering everything from the principles of model compression all the way through to some great use cases and the incredible power of your NetsPresso technology. I particularly liked a few things around showing us the recipe. Thought that was quite funny. And also intelligent transport solution. If anyone's listening from the UK who runs the M25, please get in touch because yes, having been in 6-hour traffic jams on that bit of road, I would greatly appreciate that. So it was absolutely fantastic and great for our audience to see both real life use cases as well as the principles of it. So right from the novice all through to the expert. So please do keep your questions coming in. We've got a few that have come in already, which I'll start running through. So let's talk about the NetsPresso compression tool first and foremost, because I think it's what people are really interested in. So let's go into a bit more about it. When can they use it? How long can they use the trial version for? You know, a bit more, a couple of specifics, and that'd be awesome because I think our audience would be really interested in that.
So actually, we are ready for trial version, and if you see the chat, we just uploaded the link. So please enter the link and type your some answer to the questions, and then we're gonna reply to your email address about details of the how to use and how long you can use the NetsPresso.
Awesome. Definitely go and do that, guys. It's in the chat below. If you've got any problems, just hit the chat button. And if you've got any problems finding that link, then do just let us know. But do check that out. And we've got a question in from Tal. Apologies if I mispronounced your name there. How do you configure the compression tool? Is it automatic? Can you go into a bit more detail about that and how it works?
Right. Yeah, thank you for your great question. So, the NetsPresso is designed for automatic compression. So, um, basically, it is set to be automatic. So you don't need to configure any compression pipeline. But there is also function to the manual design of the compression pipeline. So if you are very familiar with the model and the case, and you don't need any automatic uh, function, then you can design yourself manual compression pipeline. That is also open the function.
Brilliant. So you've got great customizability there and configurability, which is great. And there is a degree of automatic as well, which is also fantastic. And great question. Thanks for that. And do keep them coming in. We've had a couple come through on the chat as well from Bo Keong Kim. Apologies again if I mispronounce names. Among those compression methods that you mentioned in NetsPresso, do you have any kind of tops that you'd prefer? Do you have any ones that you'd like to particularly highlight out of the compression methods that you mentioned that you like the most?
All right. Thank you for a great question again, Bo Young. And we have introduced many compression methods, and I can say a little characteristic of each compression method. So, but the quantization, we do like quantization because it's just safe and is insane. It is very lossless and until it's into A case. But we want to go for the lower bit, but many hardwares are not ready for into 4 and or into 2. So in Dota, we are preparing for the experimental case on the into 4 or into 2. But if you want to meet to the real case, we need time for the preparation of the hardware. And about the pruning, as pruning itself is mostly uh, it's lossy because we do the structural pruning, and so it loses many information in the case. So pruning is a little bit harmful technique. Very say it's like a knife. It's very sharp, and if we misuse it, we can make some blood. So we are very um, cautious to use that. So the other one is that the filter decomposition. So it is also very safe technique because we can approximate the metrics. And FD is very good example for the hardware aware compression. So FD can be some FD tool is good for the some ARM case for CPU cases, but it's very bad for the GPU or NPU cases because filter decomposition is the number of operations is reduced, but number of layers increases. It means that it uses some parallel computing functions. That is some trade-off of the filter decomposition. So I just describe of the some characteristic of each compression method. So which method does not most like? Is that I really like all of them, and we know the I can say each characteristic, and we do combine this kind of compression techniques.
Great answer. We love them all equally. So absolutely, we love them all equally. And on the NetsPresso front, let's kind of dive in a bit more, a couple more questions around that have come in. And a great answer again, and thank you, Bokeon, for your great question there. But in terms of the time it takes, how long does it take to compress the model in NetsPresso? Is it
Right.
how long does it take? We're talking a few days, a few hours, maybe minutes, or what's the kind of time it will take?
Right. Actually, that's a very critical question and very important question as well. So we are saying that so if your model and if your training data set is not huge, and if you takes around, I can say, few hours to train your original model, then the compression pipeline goes around about 3 or 4 times than that of the training hours. So if your models are very small, so it takes around hour to train the model, and then NetsPresso is also ready for about 3 or 4 hours for making that compressed model. But if you have very huge data set, then of course the compression pipeline goes longer than gonna be longer.
And if they and let's actually dive into the models bit as well. So can you just remind us? I think you did mention it earlier, but do you support all of the open source models? Do you have a list of models that you support? Well, we will send through, I forgot to mention at the beginning, and apologies, we'll send through the slides to everyone after today's talk, and they'll be available together with the recording from today on our developer.arm.com landing page, so you can check out all the links. But do you have a list of the open source models that you support?
So actually, the NetsPresso, we are supporting the models on the slide, and we also support the classification-based model. But this NetsPresso is not ready for the other tests, such as detection or the just say the speech task or NLP task. So it is bit limited for the vision case for the first. But our NetsPresso is not for the public model, but customized model. If the operation is well known as well, then is supported as well.
We've had a couple of questions come in the Q&A, and thanks. Do keep them coming as well. We've had a couple more come in. Some are coming via the chat, some via the Q&A. That's absolutely fine. So when you compress, this is from Serge. So when you compress GPT-3, what sort of size can you achieve? And then there's a follow-up question around the pricing policy for the tool. But we'll do the technical one first, and then we'll talk about the business bits in a sec. So about compressing GPT-3 first.
Right, that's very interesting question to compress GPT-3. Unfortunately, we don't have the benchmark for the GPT-3 yet because we are focusing on the computer vision first because we thought that um, there are a lot of AI problems in the world, but um, focusing on the computer vision is the first priority of ourselves. So we are more seeing the computer vision first. So GPT-3, we are very excited to see that the result, and that's our the future plan to compress. And the next question is that what is the pricing policy for your tool? Is that sorry to say that it's a bit take time to say about the pricing policy. First of all, we want to see the customer feedback and how they feel about the NetsPresso. That's the reason why we um, run this NetsPresso trial version and session. So please use this first, and if you are satisfied, then we discuss about the price model.
Absolutely brilliant. Thank you. Fantastic answers. And let's have a look at a couple more questions that come in via the chat. And please do keep them coming. We've got about 5 minutes so left of question time. So if you needed additional performance enhancement or performance improvements on a customized model, do you offer that as a service? Could you maybe go into that in a bit more?
Right. That's also a very great question. So, NetsPresso, we do support automatic compression, but in some cases, in some data set or some models and some any say task, they might require very specific and very customized concept, such as they might regard about the recall, not just precision. Maybe they like to solve the data imbalance problem, so they may add some regulation term. The kind of specification and customization is a bit customization area and the service area of the NetsPresso. In this case, if you feel satisfaction on the NetsPresso to use the very well-known cases of the dataset and task, then we can discuss more of the professional service.
Brilliant. Thank you for that. And in the compression workflow you talked about, do you support hardware in the, I assume hardware, HW, hardware in the loop testing?
Oh, right. That's one of the most important feature of the NetsPresso. So we do test the model's performance simultaneously by connecting the model to the real hardware. So yeah, the answer is yes, and we do the hardware support in the loop testing.
Brilliant. Thank you. If you've got any other questions, do feel free to shoot them in. As I say, we've got a couple more minutes left. So this is your last chance to get in the questions before we do wrap up. I should say, again, it's a real honor to have you guys here. You're the first partner, I believe, we've had on this Tech Talk series from the Asia Pacific region. So it's a real honor to have you guys here, especially so late on. So I hope you have a line tomorrow. You know, final question there. In terms of what would you say are the kind of key differences between NetsPresso and the other, this is a question that's just come in, the kind of key differences why they should use NetsPresso versus some other compression techniques or other compression platforms?
Right. So here it's important to how to define the other compression techniques. So the first the first definition can be the compression techniques, which is written by author of the paper in the research field. And the second one is the compiler area written by Google or TF-Lite or the TensorRT, the kind of compiler can be other competitor. So in the first case, each compression method techniques is existing in the very separated form. So it's the first compression technique is written in the PyTorch in there, and the second technique is written in the TensorFlow by someone in the yellow place. It's hard to use each one. So the first benefit is that we collected all the compression techniques, we verified them all, and we are using that the compression technique. That is the first advantage of using NetsPresso. And the other one is that I just mentioned about the compiler area. The compiler area can compress the model in terms of quantization, but they did not take care of the filter decomposition and the pruning very much. So we are focusing and we are very specialized in the area. That is our key difference of NetsPresso. And one more the key difference and one advantage of NetsPresso is that we are supporting automatic compression, and also it is connected to hardware for the simultaneous testing. Yeah, that's the key differences.
Brilliant. Thank you so much. I think we will start wrapping up there. If there's any final questions that come in, we might be able to tackle them, but I think we'll just start wrapping up. So again, my thanks on behalf of the whole ARM team, AI ecosystem team, to you and Taho and your entire team who put together this awesome presentation and a great little demo as well, video as well there. We really appreciate the time. And of course, appreciate everyone turning up today. So do feel free, if you've enjoyed today's talk, to give us a tweet at ARM Software Dev and tag us there. This recording and the slides will go up in the next 24 hours. So check out our Software Developers YouTube channel. We posted a great few videos recently, one of which is an Easy as AI series. So go and check that out. A really great 4-minute demo where you can go and do a hands-on Raspberry Pi wake word demo in just a matter of minutes. It's really great. We've got, as I said, a jam-packed July coming up. So although we have a talk on July the 13th, and a July 20th talk as well. So we've got Arcturus, NXP, and then Arduino. So do check those out. Those will be the final talks for the summer before we have a little summer break. And then we'll be back with some very exciting news around an expansion to the Tech Talk series, which I'll keep you in suspense around that as to what we're going to be doing with the Tech Talk series come September, October time. Of course, as this webinar finishes, you'll be directed to fill out our survey. So please do fill that out. It just takes a couple of minutes. We really want to hear your feedback because we want to improve these tech talks going forward, make them even better for you and for your particular needs. So fill that out and we'll pick a couple of people at random when the talk finishes today within the next week or so, and we'll pick them at random. And you could be in a chance to win an Arduino Nano 33 BLE board, which is great. And it's a really great opportunity. And of course, please get in touch with Nota. They've got an awesome model compression platform, NetsPresso being launched. It's a great opportunity for you guys to have a trial version of it. Check it out, give it a go, provide them a bit of feedback and get in touch with any needs you have. So on behalf of myself and the Nota team, thank you all very much for joining today. And we hope to catch you at our next virtual tech talk in a couple of weeks' time. So thank you very much, everyone.
Thank you for joining.